Okay, so I'm done downloading the book and we'll start the class. In today's class, I'm trying to solve the chapter 1A for this decision 1 book. Now, this is your book's PDF, and if you go to the contents over here, we're just going to start with algorithms, and then we have graphs, networks, algorithm and graphs, then linear programming, simplex algorithm, and then critical path analysis, and also this route inspection and traveling salesman's problem. This is basically our chapter involving problematic creative thinking problems, requiring all the algorithm things we would actually understand from chapter 1, 2, 3, and 4 will be used over here for chapter 5. Now, again, over here, if we start with this chapter, algorithm today, this decision one maths is entirely, understanding for your programming languages. You are going to, in a future level, in a further level, if you want to continue with engineering, programming, IT related subject, then there are actually courses where they explain you these things again. So we have algorithm courses entirely where you have to understand all of these things because this one actually explains this entire unit for maths actually will explain that how the backend of any server acts. Okay, any server works. For example, if you're working with Python, so there are a few functions in Python. Now, Sharon, do you have any idea about these programming languages?
No, teacher.
Then, there are very common programming languages like Python, HTML, Java, JavaScript, right? These are very common programming languages. We code using those languages. Like we build in the entire server using those languages. And for this explanation, whenever we code, we're not going to explain every time or every step of the code in our coding part. So in order to understand for loops, while loops, or any other previous parts for Python and for JavaScript, this algorithms are important. We need to understand how to draw trace tables, how to draw truth tables, how to do mathematical induction. I think we already did mathematical induction in for the Pure Maths 1, right? So these are the concepts that will be related to your understanding for the backend of the Python or even in JavaScript also. Both will be needed for that. Now, over here, we will start with algorithms first, chapter 1. For today's class, I'm only going to explain chapter 1A, and then from the next class onwards, we will try to finish like maybe 2 units in one class. Okay, but Decision Maths 1 is extremely new. We haven't done anything like this in any of the other units for maths. For example, if you consider maybe FP1 or M2, we had did some things related to M1 or further pure maths or pure maths for other units. So they were related to other units of maths. But this further, like this is Decision Maths 1 is not related to any other units for maths. This is entirely new. Alright, so now, over here for this 1A, we do not exactly have a lot of questions. As you can see, for 1A, they have 1, 2, 3, 4 questions. Right, they have only 4 questions. So what we'll do is that we'll explain the examples over here, and also we'll explain the worksheets. Okay. So for example, for this question 1, you basically have to just understand the whatever instructions they're going to give you. For example, this example 1, these are the instructions over here, right? Now they are doing this without the trace table, but I would suggest to use trace table for all the algorithm questions. Okay, using trace table is easier. It just makes your entire math easier to work with. So they have like in the example, they have that like did this without the trace table, and we will do this with the trace table. Okay. Now, what are the instructions over here? That the happy algorithm is write down any integer and square its digits and find the sum of the squares and continue this with this number. Repeat until either the answer is 1. In this case, the number is happy, or until you get trapped in a cycle in which case the number is unhappy. Now over here, in order to understand this, for trace table, they have provided you with 70 is happy. You need to show that 70 is happy over here. So for that 70, I'm going to create 3 rows or 3 columns over here. Now, I will not, find out or like end the entire base over here because I do not know exactly where my solution would give me 1. I do not know that, but I mean, I know that there will be like 3 sections. How would I know there will be 3 sections? Because from the instructions over here, they saying that write down any integer. Okay. I mean, yes, integers could be of under 3 number also, but in your exam or in your part A, they have provided you with 70, and 70 is according to 2 significant figures. So over here, I will need 7 and 0. Right? This is 70. This is the first digit of that integer. And this is the place for your second digit of that integer. And this is going to be the sum of the squares for each digit. So let's write sum of squares. In the third instruction, I think, or in the second instruction, they were saying that square its digit and find the sum of the squares also. So over here, I started with 70, right? 7, 0. So this is going to be 7 square and 0 square. If you add them together, 7 square plus 0 square will give you 49. And then they are asking you to continue with this until you either get 1 or you get trapped in a cycle. Trapped in a cycle means that after proceeding one step, you will eventually go back to the original number. For example, if you started with 70, you will go back to 70 again. That is what it means by trapped in a circle. So trapped in a cycle. Now over here, I got 49, right? And then again for 49, I can write 4 square, 9 square, which is going to be what? Already given over here, 4 square, 9 square, will give you 97. 16 plus 81 is 97. Then again, this one is 9 square, 7 square, and this one turns out to be 130, right? So this is 130. And then again for 130 this time, this is 3 digits over here, which is going to be 1 square, then 3 square, and 0 square, which is now going to be 1 and 9, that is 10. And 10 means now you have 1 square and 0 square. At the end, you get 1, right? Over here in your instruction, it was also already stated to you that if you are going to get 1 as a final answer, then that is your end. And you got 1 for what? 70, right? You started with 70 and you could find out 1 out of this entire procedure. That means 70 is indeed a happy number. Next, we will finally show that, okay, as this matches with the algorithm's instruction, we did the summation of the digits and sum of their squares, and then found out that final answer turns out to be 1. So that means 70 is indeed a happy number. So we have proved that there's a 70 is a happy number. Happy number or algorithm? Yes, Sharon, please ask.
So teacher, if there's like a number that is 1 digit, so like for example 7, so we put 0, 7, right? First digit would be 0 and the other one would be 7, right?
Right.
Okay.
Oh, this is second, this is in 2 significant figure. If your answer or in integer is in 1 significant figure, then you can obviously write 0, 7. But over here, in this part also you got 0, 1, right? For 0, 1, if you continue this, it will keep on being ones, right? The answer would eventually be 1. It will never change. So it doesn't matter how many times you try to find out the square for 1, summation of digits and summation of the square digits, you will eventually end up with 1, right? There's no way you can get any other number out of this. So that's why this is the end. This is the stop position for your coding. Is this clear?
Yes, teacher.
Okay. Now then again, there was another number which was said that this is 4 as unhappy. Now this is in your 1 significant figure, right? So we're going to start with 0 square and 4 square. I do not actually want to explain this procedure. This is entirely easy. If you understand the trace table, then you can understand this also. Right? For trace table, I just create different columns for every term. That's just it. So over here, I'm going to start with the 4 over here again for the next part. The instructions are still same, that you need to find out the like integer and then square the digits of that integer, and then sum of the squares of the digits will be continued until you get either 1 or you end up in the cycle. So we have 4 this time. Trace table is a little bit time consuming because you have to draw this all these columns and table. But other than that, if you can draw these tables very fast, then it actually is worth it to use that all timing, because over here in the example they're obviously giving you very small questions, right? But in your exercise you'll see that they're going to give you with very large numbers. So this is going to be the first digit. Second digit and third digit. And this is going to be sum of their squares. So we started with 4. This is part B, which is only going to be 0 square, 0 square, 4 square, that is 16. It is now going to be 0 square, 1 square, 6 square, which is 37, right? Yeah, 37. It is then again 0 square, wait, 36, 37, right? So 3 square, 7 square, and which is now going to be 58. Then again 0 square, 5 square, 8 square. This one is 1 minute. 89 and 145. This is 89, and then again 0 square, 8 square, 9 square. This is 145. Now you have 1 square, 4 square, 5 square. 120, 25. This is 46. 0 square, 4 square, 6. Sorry. 4 square, 6 square. That is 52. So again 0 square, 5 square, 2 square. That is 25 and 4. Wait, 1 minute. Did I? No, 1 minute. Sorry, 1 minute. This was supposed to be 42. Okay, that was my calculation mistake. This is 1 plus 16 plus 25. Yeah, that turns out to be 42 over here, which gives you 4 square, 2 square, and that is 16 and 4, which is 20. And 20 is again 2 square, 0 square. That is going to give you 4. Now remember, you started with 4, right? You started with 4 and now you again got 4. So this is a cycle, right? This is the number you started with. You're going to get that again, that same number after completing one step. So this is going to create a cycle and you're going to get trapped in the cycle. Doesn't matter how long you go, you're going to get this exact number of coding for this next term again. So if you're going to get the exact number of coding for the next term, that means obviously it will not be that much like worth it. Right? Again, if I start breaking down 4, I will get 16, 37, 58, 89, 145, 40 to 20, and then again I'll get 4. So this is now creating one cycle and it will never end. So in order to break out this, I'll just write that 4 is now an unhappy algorithm, right? Because you do not get anything out of this, you just get the same number out of this part. So this is an unhappy algorithm. Is this clear for part B?
Yes, teacher.
Now this was easy. Let's move on to the next part. As you can see over here, they have also did the same type of procedures, right? Similar type of algorithm they have provided. But this one is not that much needed. For example, in this part, right, as you can see, they have provided you a very long algorithm, but this time they're going to multiply it. Like they want to multiply A and B together, and this is the procedure, this is the algorithm they're going to use in order to find out the product of any two numbers. So if you go back to your questions now, they are saying in 1A that in order to find out the product of these any two numbers, you have to go back to example 3 and use the algorithm in example 3 to evaluate the product of the numbers stated in each section of question 1. So for example, if I want to find out the product of 256 and 123, okay, now we are starting with question 1C, 256 with 123. 256, 123. I'll have to use this algorithm. I'll just take a copy of this and then we will go back to your other PDF. Now they have provided you with 5, or maybe there are two indentations for 2. So eventually it will be what? 7 points over here that you need to follow. Okay, the 7 points are is that make a table with 2 columns specifically and then write A in the top row of the left column and B in the top row of the right column. Okay, so let's just first work with the first instruction that we're going to create 2 columns with A on the left and B on the right. I'll just keep it like this. And now I was starting with 256 and 123. Now the next row of the table right in the left hand column, that is for A. In the left hand side we had A and in the right hand side we had B. So for A, um, the number that is half of A, ignoring the remainders. That means we had 256. That means half of 256 is 256 divided by 2 is 128. So we get 128 over here. And for B, the right hand column, the number that is double of B. So we had 123. 123 multiplied with 2 gives you 246. Let's just first write down the numbers first and then we'll start with their values. This was 256, 123, and we get 246. Okay. That is the first value we get from the algorithm. And then after this, repeat step 2 until you reach the row which has 1 in the left hand column. So you have to continue dividing it by half until we get 1. So that means 128 divided by 256 by 2 was 128. Divided by 2, this one is 64. And then again divided by 2 is 32. Then again divided by 2 is 16. Divided by 2 is 8. Divided by 2, it's 4. Then divided by 2, it's 2. And lastly, when you divide it by 2, you get 1. Right? So these are the steps. Now you can stop over here because it was stated in your third point that you need to continue dividing A until or unless you get 1. That means for all these steps, you have to multiply 2 for the column B also. So we have 246 multiplied with 2. That will be 492. And then again multiplied by 2, that will be 984. And then multiplied with 2, that gives you 1968. And then multiplied with 2, that gives you 3936. Then multiplied with 2 gives you 7, it's 7,772. So 7,872. Multiplied with 2, that is 15744. And then again multiplied with 2, that gives you 31,488. Okay, that is the final value that you get. Now, after this, after we have completed the column until or unless we got 1 for column A, now they're saying that delete all rows with the number in the left hand column is even. So we have to delete all the rows where A is even. So if I just zoom out, I can understand the first one is an even A, right? So it will be deleted. This one is also an even A. This one will also be deleted. This one is deleted. This one deleted. I think all of the numbers will be deleted, right? Because over here 256, 128, 64, 32, 16, 8, 4, 2. They are all even numbers. So only the last one will be actually accepted. That means before the last one, whatever we got, that will be all deleted over here. We'll not consider taking that as a part of our calculation, that because it was stated in your option 4 that we need to delete all the rows where the left hand column is even, where this column A was even. That means finally the sum of the final sum of the non-deleted numbers in the right column, that is the product for AB. That means over here the sum of the non-deleted columns over here is only this last one, right? Only the last one was not deleted. Other than that, all of the other columns were deleted. That means we are only going to accept this 31488. That means finally, according to your algorithm, the product of AB, which was basically the product of 123, so 256 with 123 is going to be 31488. There's nothing to add this 31488 with something because everything before that was cancelled. Because for every part of A other than this last one, A was even. Right? That's why we have to cancel all of those things. So finally, you can check your answer also. 256 multiplied with 153 does give you 31488. So this is your algorithm for question 1C. We did not do any kind of mathematical instructions or understanding for decision maths. Over here, whatever the instruction that was provided to me by the code, I will just apply that and complete my trace table according to that. Okay, I'm not going to use any of my basic knowledge on it. Sharon, is this clear?
Yes, teacher.
Okay, let's just do another maths for this same part. Then again, you have what? Wait 1 minute. Sorry. You have 125 and 244, right? So we can start with that 125 and 244. Now again, our first part would be to create two columns, one with A and one with B. For A now we have 125 and B is 244. So this is 125, 244. Half of 125 is going to be a fraction, but then again, if you remember the code, they were saying this that without the denominator, without the remainder, ignoring the remainder, okay, we're not going to consider the remainders. So 125 divided by 2 actually gives you 62 half. Okay, over here, this is what you get 62, 62, 1 half. This is your quotient, this is your remainder, and this was your divisor, right? So the only quotient we're going to use over here that is going to make it 62. We're not going to take the remainder, or not going to keep this into any fractions also. 16 half, 62.5, these are not accepted. We just have to carry out the quotient every time, ignoring any remainder if you have that. So half of this, 62 divided by 2, again gives you 31. Half of 31 gives you 15. This is 15.5, but again we're ignoring the remainders. So we have 15. 15 divided by 2 again gives you 7.5, which is 7 half. Again, we are not considering half. We have 7 only. And then 7 divided by 2 gives you uh, 3 halves. So this is just going to be 3. Then 3 divided by 2 gives you 1 half. Okay, so now you're going to get 1. So this is your last stage, right? We're supposed to stop the entire trace table whenever you're going to get 1 for the column A. And then you can continue for column B by multiplying every number with twice, right? We just have to double every point. So 244 with 2 turns out to be 488. Multiplied with 2 is 976. 2 is 1952. And then multiplied with 2 is 3904. And then multiplying with 2 gives you 7808. And then again multiplied with 2 gives you 15616. According to our algorithm, what was the case? That we need to cancel out all the rows where column A was even. So for column A was even, for this one, column A was even. Only this one for column A was even, right? For all the other numbers, it was not even. 25, 31, 15, 7, 3, 1. They're all not even. So that means I have to now find out the summation, right? Summation for column B will give you the product for A and B. So for the last part, I can write AB is actually now going to be equals to summation of B, right? And summation of B is equals to 244. Then, 244 plus 976 plus 1952 plus 3904, 7808, and 15616. Let me just check 1 minute. 244 976 1952 3904 708 15616. So you're going to get 30500. And AB was 125 multiplied with 244. Right? So this is what you get for the A and B, product for A and B. Is this clear? Yes, Varun, please ask.
Teacher, why did we cut out the 62 and 488?
Sorry, I didn't understand. What? 62 and?
For 488, the second
Yeah,
row?
yes, I have to cancel that, right? Because it was stated in this state that delete all rows where the number in the left-hand column is even. They're talking about delete all the rows for which A was even. So with this entire math now, only 62 was even, right? Other than that, every other number was not even. So we're going to add these values, but not this one. Because for this one, column A was even.
Oh, okay, teacher.
Now let me tell you where this entire function is actually used for. Okay. For this, I'll open my another screen. 1 minute. Now these are the basic understanding for algorithms working for languages. Now, so far in my university classes, I have actually um, like practiced only one language, even though I was supposed to study more than one, but I could not actually manage time. So, lab 1 minute. I can open VS Code, but this time VS Code will be not that much sufficient because I have this Google Meet already on and all these tabs. I cannot cancel this. So let me just tell you over here. 1 minute. Okay, let's start with this one. Okay. Now, if you in Python, if you want to maybe find out the product of any numbers, okay. For example, I'm going to consider like in Python we actually name variables. For example, A is maybe 4 and B is equals to 3, right? That means at the end, if I'm going to write print A star B, and then now if I run this code, it will just take some time because this is the first code for this collab file. This is connecting. You get 12, right? This is the coding part. I mean, for your collab, they are a compiler for programming. So this one entirely compiles your understanding that, okay, 4 multiplies with 3 gives you 12. But now we know how we get 12 over here. Using trace table, we know that exactly using the same procedure we did for question 1 over there, right? This is how we actually use programming to find out the find out any product of any two integers, right? This is how we get 12. So in algorithm, in the entire decision maths one, we're going to understand exactly how programs work. This is the back end of the program. This is the front end of the program. We just have to know these symbols over here. This star mark you can see on the screen indicates multiplication in Python. Okay. There are different symbols for different languages, but so far I only know Python, so I could only explain decision maths with Python understandings. But obviously, these things are not needed for your exam. You do not need to carry out Python programming in your exam, but this is like the actual application for your decision maths. For all the other maths, we saw, we are going to see integration in P4, integration in P3. We even saw integration in P1, P2, right? And then we saw M1, mechanical concepts, projectile motions. Like those are kind of physical examples that I would have to use. For example, integration I use for parabolic structures. Maybe the curving part of the bridge, they are the final application for integration equations that we do for P4, P2, P3, P1, right? So I do not have access to those examples, but I have access for decision maths one. Like all the algorithms, all the chapters we're going to see with programming so that, you can actually connect that, okay, where these are actually getting used. Is there any problem so far?
No, teacher.
Okay. Also, I would suggest that as I was saying, that I would suggest that since you are actually taking an entire year and you have 1 or 2 months free, right, within this time, I would suggest since you have taken A-level further maths, try to take maybe few courses for programming languages. For example, what courses you can actually buy, not exactly buy also, you can actually get free courses from Coursera. You can take financial aid from that, and they will give you their courses for free, and you can actually learn this kind of languages, which will actually help in your maths and eventually in your further studies. For example, the subjects you took in A levels, maths, physics, and maths, further maths, right, and chemistry. These are all engineering subjects. So, I mean, there's no way you can actually shift to biology. You actually have to stick to engineering subjects. So, I mean, what are your plannings, by the way, in order to carry out for the further studies?
Well, my idea teacher is to become an electrical and electronic engineer,
Okay,
like my uncle.
Okay. For electronic engineers also, then you can actually understand. I mean, for electronic engineers, Python and HTML will actually be needed. For example, in my university also, we have to create some bots and we have to create few cars and robots. And for those, obviously, we need to understand the mechanism for physics, right? Because we are trying to make that object move. Right, for electronic engineering also, you have to work with for your university courses, you have to work with bots and um, any type of car that needs to move, sensor car. So for those sensor car, in order to create those sensor car, there's some programming chip that you have to fit in inside those cars, so that maybe they would sense colors, they would sense changes to the surroundings. So these type of changes can only be fitted inside the car, inside the chip, using programming languages. So there are actually a few channels that you can follow. What was the channel's name? 1 minute. Yeah. Python with Mosh Hamdani. Okay, I would actually suggest start watching these videos, because eventually you will need programming languages for your university courses. Even though you're going to be an electrical engineer, like my major is actually computer science and engineering. So for engineering also, I have few courses which are going to be like common for electric engineers. So for electric engineers also, Python and HTML is actually the basic language that is needed for your build-up of any mechanism. So I would suggest start learning the basics of Python or the basics of HTML within these 2 months. Since now you have a summer break, right? You don't have that much pressure, so start understanding with these few things. It will be related to you for your university admission. Also, are you going to plan? Like, are you planning to stay in Qatar, or are you going to strive for abroad universities?
I think in Qatar there's only one university, which is Qatar University, and one other university closed down recently. But
Oh,
yeah, so there were only two universities so far that
um,
I knew of. So I might apply abroad.
okay. Do you have any specific country where you want to apply?
Nothing specific, but my parents want to send me to Canada, I think, or
Okay.
UK, one of those two.
Okay. If you're trying for UK, then they will not give you any scholarship, right? For UK, the university won't provide you with scholarship. But if you're going to try for Canada, then they do provide scholarships. So I would suggest that for electrical engineering again, what you can do is that you can create when using Python and HTML, and also using very simple little videos. You can actually create a simple website for your for your blogging. Okay. So what happens is that when you create a website according to your personality, like you have created a website where it shows your maybe whatever the subjects you took in O levels, in A levels, and what are your interests, what are your hobbies, and then you can actually create few RGB materials. For example, you can create a highlighting board or something, right? Which can actually create different sections for light, which can actually change their light theme. This will be related for your major, according to as you're trying to do electrical engineering. Creating a website for you will actually make your application very stand out from the other kids who are also going to apply to those universities, right? So I would suggest try to understand Python, try to understand HTML, then try to find out how to create a website. I'll actually give you one video tutorial to actually that they entirely teach you exactly how to create a website, a very basic website that doesn't require that much of Python and HTML. You can easily do that by just copy and paste and whatever that they are doing in the video. Just copy paste that and paste it to your, and then just change few things, change the dialect, change the font, change the color, and then you can actually create your own website in WordPress. Okay, so these things are actually will make your entire application very unique compared to the other students. And also for Canada, they do provide scholarships. If you, I mean, you already have nice results, right? So if you are going to have like few extracurricular activities, then you can also apply for United States, and you can again get scholarship. Like United States give you the maximum number of scholarships.
Yeah.
Okay, so another thing again, if you want to stay in um, Asian countries, then there is South Korea, KAIST. There's this university. KAIST is actually among one of the 37 top 37 universities in the entire world, and KAIST has the best labs for electrical engineering, and they get a lot of funding. So from KAIST, actually, what you can do is that you can do your undergraduation in electrical engineering, and then you can move on to AI. Not exactly AI, you can move on to maybe mechatronics or robotics related to your concepts. Like if you find that interesting, then right? But working under a university that has a very large amount of research fund actually makes you look around the environment very easily. For Canada, if you're going to apply, I would suggest apply for Caltech, Alberta, and also I would suggest that maybe give it a try for KAIST also. Right, because KAIST is extremely like a developing university, and they have a lot of large amount of research fund. So large amount of research fund, you will actually see a lot of experiments going on there. So that will make you experience a lot. Okay, that will make you make you learn about new things about the environment a lot that you won't be able to see in Caltech or in Alberta. So I would suggest go to these Asian universities also if you can. Right. Enough of
Okay.
university admissions. Wait 1 minute. Yeah, okay, let's start with this one, as I was saying. Okay, now then again over here they have provided you with a different amount of code, and the below box below describes an algorithm. Write the input numbers in the form of A by B and C by D, and then again you have to suggest that let A is equals to A multiplied with B and B as B multiplied with A plus B multiplied with C, and your final answer is going to be E and F. Now you can understand, right? This print over here on my Python program, right? Over there also, I was actually writing that print A star B. If you remember, uh, I put the value for 4 under the variable A, and then again I put the value for 3 under the variable C, under the variable B, and then I started writing print A star B. Right, the print function is actually a built-in function for all the languages. Okay, this one actually tells you that whatever the behind this code is, doesn't matter whatever how many steps behind the code is, you're just going to get the final answer. If you're going to write print the final code. Okay, print the final code means you're just going to get the final answer over here. They're not going to give you the the basic understandings over here. In my collab file, when I was showing that A multiplied with B will give you entirely the final answer will only program this part. It will not find out that what was written on line 1, what was written on line 2. It will not try to explain you the basics or behind the work for line 1 and 2. It will only explain you line 3. Print A multiplied with B. Okay. So that's why again we wrote print over here. So this is going to be your final answer. And then again for your answer, there's supposed to be one string. One thing to understand in algorithm, in decision maths 1 and also for programming, answer all the numbers are considered as integers. Okay, one thing, let me just write this down. Um, Whole numbers, okay, these are known as integers in your any kind of programming language or algorithm or everything. Algorithm actually, according to decision maths 1, they are only focusing on Python. They're not going to base this on JavaScript, because JavaScript is extremely tough to understand. For me also, this is tough to understand. So they're not explaining all this algorithm in terms of JavaScript. They are explaining this in terms of Python. Okay, so this is integer, and sorry. And then if you have maybe decimal numbers, okay, decimal numbers, these will be represented as floats. And then again, if you have words or alphabets, for example, in this part, this answer over here, right? So words, these are known as strings. Okay. Now remember, the strings cannot be calculated. You cannot provide any formula for strings, but there are formulas for integers and floats. You can multiply the integers, you can divide the integers, you can add the integers, you can subtract the integers. And that is the same case for floats also. You can add, multiply, subtract, divide, but there is no formula for strings. Okay. Are the three words clear to you? Sharon, any questions for this part?
No, teacher.
Now they're saying that implement this algorithm with the input numbers 2, 1 by 4, 1, 1 by 3. First thing your laptop would find, whatever you're using, the compiler would have to convert this mixed fractions into I'm so sorry. Uh, okay, as I was saying that first your laptop or compiler, whatever you're using, have to convert these mixed numbers into improper fractions. Sorry, so you have this 2 1 by 4, right? So 2 1 by 4 turns out to be 9 by 4 maybe, right? Yeah, just 1 minute, Sharon. Okay, as I was saying, the first thing your compiler has to first convert these mixed fractions into improper fraction, right? This is going to be 9 by 4 and 1 by 3 is going to be 4 by 3. This is your 4 numbers. That means according to this, A is 9, B is 4, then C is also 4, D is 3 this time. So you're going to get that you have to write down now 1, 2, 3, as there are 4 alphabets, 1, 2, 3, 4 alphabets, A, B, C, D, and then we have E and F, and then again for the answer part, we have to divide E and F together, right? So there's going to be 1, 2, 3, 4, 5, 6, 7 columns for this part. Even though I'm not taking multiple values, I'm taking just one value over there. A, B, C, D. Yeah, okay, this much is enough. Okay. And this is for A, B, C, D, E, F, and then E over F. Okay. So for this part, the value for A was, I took it as 4, 9, 4, 4, and then 3. And for E, the formula was what? AD, right? For calculating E, we have a formula A multiplied with D, which is going to be AD. And then for this one, this was B and C. So for AD, we have 9 into 3, that's 27. So 9 multiplied with 3, that's 27. And then again, 4 multiplied with 4, which is going to be 16. So these are your values for E and F. Final answer is going to be E and F. E and F is going to be 27 over 16. So if you now get 27 over 16, you're going to get 27 over 16. You cannot break this down. If you break this down, it actually gives you in decimals. So I'll just write this down as 25 over 16. So answer is going to be Answer is 27 over 16. Remember that it was stated over here inside colon that print answer is E over F, right? You're supposed to write answer is 27 over 16. So then again, this was the entire algorithm for part 2A. And now it says that for part B, what does this algorithm do? Can you tell me what does this algorithm do over here? Like, what is the main function over here? Like what do you get over here for the final part? You can understand this 1 minute. We had this A, B, C, D, right? I'll just explain this to you. we have A divided by B multiplied with C divided, multiplied, we have these two fractions, C divided by D. In E, we got AD, and in F, we had BC. So when we are dividing E over F, so we have to divide AD divided by BC. One thing to understand exactly how we can get the two fractions out of this. EF is equals to AD divided by BC. I can write E over F, that is basically A by B multiplied with D by C, which can be again written as A by B divided by C by D. Now you can understand that basically E over F is basically the fraction of, like this was fraction 1 minute, this was fraction 1, and this was fraction 2. So you basically are getting, this entire algorithm does what for you? It's just going to divide your first fraction with the second fraction. But according to our basic algebra classes, we know that this, whenever the denominator is in divided format, it gets inverted and multiplied with the numerator, right? And if you simplify it, you're going to get this stuff, right? So if in this entire algorithm, this is how the algorithm will work. I mean, for you, I think you can understand it easily from this two fractions. If you want to find out whatever the value for, I mean, if you want to divide these two fractions, I can easily invert this and multiply with my numerator. But your algorithm will not work with like this. Your programmings will not work like this. For programmings, this is the entire process how you have to get this entire basic algebra, where two fractions are actually divided in a divided format. The denominator will get divided, or the denominator will actually get inverted and gets multiplied with the numerator, right? So this is the entire procedure. That is how the algorithm actually does that. Is this clear, or should I explain this to you again?
It's clear, teacher.
Just 1 minute, please. Okay, Sharon. As I was saying, now over here, I mean, I obviously input this entire function for one variables, right? Now, again, in this function, they were saying input numbers in the form A and B. So if I again have to show this, the basic, like how would they look like in programs? I'll just explain this to you again very quick. 1 minute. I'll stop the screen over here and we'll start the screen from my other hand. Yeah, you can see my screen, right? Yeah. But for this time, if you remember, they were asking input the values of A and B, right? So basically, this is how it actually works. A is equals to, this is actually a built-in function again for Python. This is going to be like input. Now, inside input, you can actually add any string value. String value means that maybe you want to input that write down the value for A. Okay? That is your string value. And string value should always be uh, inside this apostrophes over here. So I will just write that write down your value for A. Okay, and you just want to first print out this. So it's just going to be print A, and if you run this code, then you can actually add any value to this code. Like this box over here appears, that means you can take values from the user and get this code running. So I'm just going to write maybe the value for A was what, 9, right? So this is going to be 9, and we're going to get 9 over here for the final answer, right? So using this same basic, I can actually use the same code for B, C, D, E. for BCD, because we're only taking codes for BCD, numbers for BCD, and then for E and F, we will actually, like multiplying them, right? So for P again, I can do the same procedure. I'll just copy this. Instead, now I'll just even like replace A with B this time every point. Sorry. I know this might sound a little useless, that we don't need this for a decision math, then why am I showing this? Because it just makes it entire maths a little bit clear. Just 1 minute. Okay, now we have calculated, or now we are going to take the different values for A, B, C, D from the users. And now I can add this, or like what was the value for E? For E, it was A multiplied with D. So now I can write E as its last variable, and that will be A multiplied with B. Right, and then again F, that is going to be B multiplied with, sorry, it was this is going to be B multiplied with C, right? And now if you write, now from this part, if you write print E maybe, and then again if I write print F, sorry, print F, if I go back, now if you run the code again, now they will ask you for the value for A. I'll put the value for A as 9. Okay. That you press equal, and then they ask you for the value for B. You can understand that this compiler is reading the code line by line, right? First they ask for value for B, and then they print the value for A, and then they ask for value for B. You can see this green line over here, this arrow over here. This is one. This is the one that reads the entire code line by line. So for B now, I will write 4, press enter, then the line moves to C. Right, for C, the value was again 4, press enter, then the value would, or the compiler will move to D. D was 3, so you press enter, and then, wait 1 minute, what happened? D is A multiplied with 3. Syntax error, input. Wait. From this part, you can also count multiply sequence in non-integer. Oh, this were in, sorry, this were in string format, sorry. For example, this problem over here, if you understand this, for point D, this was in a string format, right? We're only taking the values for strings. We were not actually, they were not under in an float or integer. Like at the very start of this question too, I suggested that we could only multiply or divide or add or subtract for strings and floats. So for integers and floats, we cannot multiply or divide or any other mathematical things on strings, right? This is D over here is basically a string function where we were like taking the values, but we were not actually using them, right? So in this part, then I would actually have to change the code maybe. For example, I just easily write that 9, sorry, not 9. Then again, I actually have to change the code. For example, there will be a different variable where I will store the variables for variable A and variable B and C and D. Wait 1 minute. Yeah, input A, and then then I actually have to store the variables in a different part. So that I can suggest as I'll actually store this after this. Okay, 1 minute. Or I'm not going to store this. I'll just directly write down the answers over here. So it will be 9 multiplied with 4. 9 multiplied with 4, and for if this time this was 4 multiplied with 3. So previously it was 9 multiplied with 3, and this was 4 multiplied with 4. So now again, if I run the code, this time it will not be an error. I'll write 9, then enter, then again 4, enter, then again 4, enter, and then lastly 3, enter. Right, you're going to get 27 and 16. Now for the final answer, it was actually the fraction for E and F, right? So for this part, I can write another, for this, as this is going to be your answer, right? Final answer. So I just write, I can create a variable with the name A and S, right? And this will be equals to E divided by F. And now we will write print ANS. Okay. Now again, if you run the code, 9 enter, 4 enter, 9 enter, 3 enter, and you're going to get this one. Now then again, you are getting this as what? You're getting this as float, right? 1.68 75. You can actually convert this float into integer also in this built-in function again. For this built-in function to apply it, you just have to write int. Whatever the answer is, you just have to apply int with that. And now again, if you write your answer, your final answer will be in integers. So 9, 4, 4, and last one was 3, right? You're getting just the integer over here. That was 1 because your float was 1.6675. So you're getting, like, this one is entirely rounding this up into one significant figure. So that's why you're going to get just 1 over here. This is the entire programming for question 2. Right? The back end of question 2 was explained using the trace table. And this is the front end, how the front end would look like. Is there any question?
No, teacher, no questions.
Then again, I'll stop this screen and we will start with this. Similarly, we'll start with, okay, 1 minute. That means for part B now, what was this algorithm doing over here in January? It was actually dividing the first fraction with the second fraction, right? Because this portion actually explained that how you got AD divided by BC will actually be A divided by B divided by C divided by C. D. That means for this algorithm actually is dividing the first fraction with the second fraction. That is how the basic algebra is broken down in compiler, in codings. So for part B now, we'll write that with second fraction. Okay. Now we're done with question 2. Let's move to 3. Hmm. 1 minute. For 3 and C is about series. Right? Yeah, C is about series. So let's start with okay, now for 3, it says that the box below describes an algorithm. Let A is equals to 1 and N is equals to also 1. This time, we're not going to take any input from the user, right? This is fixed algorithm. The value for A is 1, N is 1, and we need to first print A. That means on a compiler, we're going to write that print A and that will give you the value for 1, right? Print A will obviously give you 1. And then it says that let A, this time is going to be A multiplied A added with 2N plus 1. And then again, you're going to change the value for N again. So which is going to be N plus 1. And this will continue until and unless if the value for n is less than equals to 10. Okay. So exactly how do you get like in your compiler, how would this entire thing work? Right over here, what this actually indicates, it will continue to go back every time. It will continue to go back. First they will print out the value for a, and after that they will move forward and then again go back. They will move forward and again go back. And for how many times they will go back? Until or unless the value for n is 10. So from this part, maybe if we get the value for a as so n as 8 also, that is still less than 10, right? So again they will go back, right? For the n equals to 9, they will also go back. For n equals to 10, they will also go back because this time it was if n is equals to 1. So if n is less than equal to 10, right? Less than equals to 10 means that up to the value for n equals to 10, every time they'll go back. And after that, when n becomes 11, then we will stop the code, right? We'll stop the code when n is 11. That means over here, your range is what? Range is that if n starts from 1 and ends at 10. There's a fixed range. Range is 1 and 10. Okay, this is your range over here. And then we can obviously start with the algorithm. We have a and n over here, right? And then again, there is a print function also because we are printing a every time. So this is a print function. So we will have what? 3 columns over here for a, n, and the print function. Is the question clear to you, Sharon? Any questions from this part?
No, teacher.
Hmm? I'm not sure if you're actually understanding things or not.
No, teacher, I understand it.
Okay. If you have any problem, please let me know because I know decision maths is a little bit different, right? I mean, what are your reviews so far? What do you think? Is it good or bad?
I mean, it's full of programming, a lot
It
of
is.
formulas.
Sorry, lot of?
Formulas and trying to get something out of something else.
Right. They're connecting to everything. They will not have any formulas. For algorithm, you'll not get any formulas. Actually, the things I was using in the compiler, that was for Python. You do not need to show that the front end. Okay. Other than that, there are actually no formulas. They are using basics of language. So I would actually suggest that if you can watch the videos, I'll actually give you the link. Okay, Python with Moshandani. So then these algorithms will be very easy to connect it with the Python tutorials. 1 minute. A B. I think I have added too many rows. I'll just have to delete it. Actually, let's just keep this much. Even though we don't need this, but we'll just keep it. These are needed. 1, A, B, and print function. Right. This is value for A, this is value for N, and this is your print A. Okay. Even though they're using capital A in Python, you cannot use capital A. You have to use small numbers as the name for variables. Okay. Now, the first value for A was 1, N was 1, right? So if A was 1, N was 1, and if you're going to print A, we're going to get 1, right? And then again, if you go back this time, for this one, it was supposed to be what? N plus 1. So if the value for N was 1, wait, another thing, using this function, using this N equals to 1, we will complete this step 3 also, right? For step 2, we printed A. Wait, 1 minute. This is how it actually is supposed to be over here. 1 minute. This is step 1. Okay. This is step 1. We input the functions, like we input the value for the variable A and N into the function, right? This is step 1. For step 2 now, they're going to print A. So this is step 2. For print A, this is here, we're going to get 1 because the value for A was 1. And as we saw in the compiler also, that coding only does by line, right? Before step 2, we had step 1, and in step 1, the value for A was 1. So this is the procedure for step 2. The answer we're going to get for A is 1 in step 2. For step 3 now, before step 3, the value for A was 1, N was 1. So for step 3, we got a 2n plus 1. We have to now find out the formula over here. So which is going to be 1 plus 2, 1 plus 1. Because before step 3, the values for a was 1, b was, n was 1. There's going to be 1 plus 2 plus 1, that's going to be 4. Right, so over here for step 3, you're going to get 4. And then again, after step 3, we have step 4. Step 4 is what? Print n plus 1. So this time again, wait, sorry, made a mistake. This was the value for a. Right, in step 3, we got the value for a. And in step 4, now we're going to get n plus 1. Previously, whatever the value for n was, we're just going to add that with another one to get the answer for step 4, which is going to be now 2. Is there any questions for this part?
No questions, teacher.
Okay. Now, after this, they are saying that if the value for n in step 5 is less than 10, you need to go back to step 2, right? Then again, this is what? We got the value for n as 2, that is less than 10. Right, so we need to go back to step 2. Before we go back to step 2, let's just create a column. I don't think I would have enough space to complete this code. Okay, I would need to move back to the next page, no problem. Now I have to write a statement over here. That the statement was what? That if n is less than equals to 10, go back to step 2 again, right? And in step 2, what was this? Print a, right? So then again over here from this part, I will write step 2. For step 2, print a means 4 because previously, before this step, the last value for a was 4. So we're going to get the value for a in the print section as 4. Then again, I'll continue. After step 2, we'll move on to step 3. The new value for a was 4, and this time the new value for n was 2. So this time the formula would be 4 plus 2, 2 plus 1, right? Yes, which is 8 and 9, right? This one becomes now 9, right? So this is now going to be step 3, which is now 9. Sorry, 9 was over here supposed to be 9. And then again for step 4, new value for n, this time it will be 3 because previously the value for n was 2, 2 plus 1 makes it 3. I will have to extend the lines. This is going to be a very lengthy code. 1 minute. And this is going to be step 4. This is going to be 3. And then again, I got what? N is still less than equals to 3, less than equals to 10, right? Because if you remember, step 5 was that if n is less than equals to 10, go back to 2, step 2. This is, by the way, step 5. Right? Then again, for step 5, I'm again go back to for step 6 this time, again, I'm going to go back to step 2. So for step 5, again, the same procedure happens. I'll just copy this. Okay. Now you're going to get again step 3, so it's step 2, which is now going to be what? Print a. Last time the value for a was 9, so I'm going to get 9 over here. Let's similarly continue as we can. 1 minute. We again have to extend these lines. Wait, I cannot extend the lines. Wait. Um, I would actually have to, draw another file over here. 1 minute. Just give me a minute. I'll just copy this. Okay. Now for this one, this is going to be step 3. And in step 3 again, we print A, right? Sorry, no, we print A, and the value for A was A plus 2n plus 1. So this time the last value for A was 9 and n was 3. So it will make it 9 plus 2, 3 plus 1. That's 9 plus 6 is 15. Yeah, 15 plus 1 is 16. So you get the step 3 value as 16. And for step 5, so step 4 now, we print the new value for n, which is n plus 1. So 3 plus 1 is 4. And again, this is what? Less than equals to 5. This one will be over here now. Right, less than equals to 5. This is step 5. And then again, we go back to step 2. Right? So this is step 2 again. For step 2, we print the value for A, which was 16. And for 16 again, we calculate, we move on to step 3. Step 3 is the new value for A, which is 16 plus 2n plus 1. And over here was 4, so 16 plus 2, 4 plus 1, which is now 25. And for step 4, it becomes n plus 1, that is 5. So this is 5. And then again, step 5 is going to be same, and is still less than equals to 5, right? So this is 5. Finally, again, go back to step 2. This is going to be 25. I mean, this is a very repetitive pattern, right? Nothing changes over here. So let's continue with this. Step 3 is going to be again what? 25 plus 2 multiplied with 5 plus 1, that is 36. 36. And then again for step 4, we get 5 plus 1, that is 6. And this is again, this is again less than equals to 1, right? Yeah, this is again less than equals to 1. This is step 5 again. And we need to still continue that. Just 1 minute, Sharon. I'm just taking a lot to complete this, but we need to complete this to understand part B also, okay? So there's no other way around. Also, are you understanding this? If you have any problem, please ask.
No problem, teacher.
Okay, then I will continue. I mean, this actually doesn't have anything changed, right? I'll just have to continue this until or unless I get the value for n as 10. So, which is going to be step 2. That's again going to print A, that is last value for A was 36. Then again, step 3, new value for A is A plus 2n plus 1, right? 36 plus 2, 6 plus 1, which is now going to be 49. And then step 3, so it's step 4, which is going to be 6 plus 1, right? That is 7. And then again, this is what? Still less than 5, so still less than 10. So I'm just going to write this, that n is still less than equals to 10. So we're going to go back to step 2 again. This is step 5, then step 2 is print A, which is 49. And then step 3, this is going to be the new value for A, 49 plus 2, 7 plus 1, which is going to be 64. Copy this. Okay, now for step 4 this time, this is going to be 7 plus 1, so 8. And this is step 5, which is going to be this one. Right, and then again for step 2, it will print 64. Right, and then again for what? Step 3, new value for A, 64 plus 2 multiplied with 8 plus 1. This gives you 81. A new value for n is 8 plus 1 is 9. And this is still less than equals to 10. This is step 5. And then again, go back to step 2. That will print out 81. Then step 3, new value for 81. 81 plus 2, 9 plus 1, that gives you 100. And now you get what? 9 plus 1 is 10. And this is now equals to 10, right? Finally, we get to our final stage. This time we'll write a different ending. We get the value for n equals to 10, right? So this is going to be your step 6. Stop. That means this is a final answer. Over here, what you can actually understand from the print values, right? These are the values that will be given in your compiler. Remember that for A and N, all these things, you're not going to get this on your compiler, right? You're going to just get this in the insides of your compiler. These are the values that you're going to get in a compiler. For print values, these are the values you're going to get in a compiler. So what are the values? 1, that is basically 1 square. 2, 4 is basically 2 square. 3, 3 square is 9. 4 square is 16. Then you have 25 square. 5 square 25. 6 square 36. And 7 square 49. And then 8 square 64. 81. So that is 9 square 81, right? So you're actually going to get the square for all the numbers up to 10, right? But not 10, because for the value for 10, it will not get printed, right? Oh no, sorry. For 10 also it will get printed. It will not get printed for greater than 10, right? There's again supposed to be another last step. This is not going to be the final stage, because you're going to get last step as your stop step after the value for n becomes 11, not 10. So there will be just one, like 3 more sections over here. So again, we go back to step 2, which is going to be 100, and step 3 is going to be like 121. I already can understand. Okay, 121, and step 4 is now going to be 11. Now we're going to write that stop sign over here, because now n is greater than 11, and we're not going to take in the like value for n as greater than 11. So in the last compiler, in the output over here, in the print section, or output of this entire code, you are actually getting 1, 4, 9, 16, 36, sorry, 25, 36, 25, 36, 49, 64, 81, and 100, right? These were the numbers you got as the output for your entire coding. Is there any problem so far?
No, teacher.
Did you understand that why we are taking only the print function over here as your final output? Sharon, did you understand that why we are taking only the print function and not the values for A and N?
So because we substitute each new value as a and then n.
That's because no. On your compiler, when I was showing you the code, right, over here, A was 4, B was 3, right? These are the values inside the compiler. On your screen, you actually see these values. Right, these are actually again in the backend. Okay, you have fixed these values as your programmer in the back end of your server, at the back end of your server. But when I am going to find out that maybe find like we have actually made a compiler in your front end also that is connected to your back end. Like find out the product of any numbers. Okay, that is on your front end, and then I want to find out the product of 4 into 3. So I press on that, and then on your screen you print out only A multiplied with B, and that will give me 12. So this is on your screen. So print variable is on your screen. So that's why we're getting only these parts on your screen, not all of the values for A and N. Is this clear?
Yeah, yeah, this teacher.
Okay, for A and N, the values for A and N were in the values for the algorithm, were in the backend working, right? On your screen, you're only going to get the values for print. Okay, whatever the value for print was, that is what you're going to see on the screen. Okay, now over here, let's go back to your question. For question 3, describe the numbers produced by the algorithm. They are what? Square of each number, each value for n, right? For every part, when the value for n increases, you get a square numbers, right? Square of those numbers. So basically, you're getting the algorithm produces the square of the first 10 numbers. Right? That is what the algorithm is giving you over here. Sorry. For part B now, this algorithm, 1 minute. This algo produces the square of first 10 numbers. First 10 numbers. Wait, sorry. 1 minute. Read this question, read the entire instructions, and let me know if you have any problems so far.
Understood, teacher.
Okay. Then for the last part, I'll explain you that this was just the back end of your program, right? And how the content look like. We're going to end the class over here, and then you can decide if you want to continue with decision 1 or not. I will just open my other file. Now you can see my screen, right? Now again, these are actually the basics for Python. Okay, I'm not actually using any conditions or other building functions other than print. In Python, there are actually if conditions that you can apply. You can also apply for loops, while loops. But this one, then you have to continuously go back to the value for n. Over here, you saw that on step 5, if the value for n is not less than, is not actually, yeah, up to a 10, up to 10 or less than 10, you have to go back to your step 2, right? That means the condition over here was that your value for n should be greater than 10, right? In order to prevent that loop. Right. If you don't want to go around that loop, then your value for n should be greater than 10. That is a condition. So for that condition, you can actually create any code using a loop function over here. Using a loop function. Sorry. So for that loop function, we actually generate I is equals to 2. Then we are going to write the first number as 1. First number as 1. Because I know in your what was that? In my code, the value for A was 1, right? And the value for N was also 1. So I would write x equals to, x is basically the value for A, by the way. Okay? X equals to 1. Or you can actually take input from the user also. Like what would be the value for x? So you'd ask them. You can also use that using this function that input write down the value for x, write down the value for a. You can also take answer from your input from your user. So I'll just fix it over here first, right? Okay, for this part, we'll now start using while loop. Whenever you work with loops that in your programming, you need to go back to a specific step in order to get the final answer. Like over here, the condition was that the value for n should be greater than 11 to prevent that loop to occur, right? So over here, the entire condition is going to be 10 greater than equals to n, which actually indicates what? That over here, the value for n should be greater than 10 to prevent this loop to occur, right? If the value for n is not greater than 10, every time the loop will occur. Right? Every time the loop will continue when you're going to move on to step 4. Now this part is equals to, oh wait, sorry. As I'm using n over here, so let's just use n in this part. Now for J in range. Over here on your exam, on your paper also we wrote range, right? Range was what? Range was for 1 to 10. We want to find out the range for the first 10 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for that again, I have for J in range, our starting value was 1 and our ending value was, this time I'm going to write I because every point it gets added with 2, right? Then after this, 1 minute, then if I can write x equals to 1, then again another while loop we have to run down. 1 minute. Let me just bring this. Okay, let me just write this code and I'll explain this to you later. Okay, let me just write this code. For chain range, IN1 x equals to 1. Yeah, we have to find out the, yeah. Chain. If we are installed, then we're going to print out. Sorry, 1 minute. If then it's, yeah, then we're going to print J. And if this is not equals to, then we're going to add 1. And this should be under normal interpretation. And J should be equals to 1. I think this should work on way. Let me just run this and see if this has any problem. This one. Oh, right. No. Then there are some problems. Every time I'm getting just 1. Um, I did spare them. If this is spared to equal, print J or else this. Or maybe I can also use, let me just use another compiler. I can use for loop also for I in range. This is going to be 1 to 11. And then I can write print I multiplied with I. But this one should give you the final answer, I think. So I'll just delete the previous one. So this one is still running. Now I can run this one. I think this one will give you the final answer. Because over here, on your question, the range was also for 1 to 11, right? 27% false. Yeah, this one gives you the final answer. So I in range 1 and 11, and I multiplied with I. Right? This time, it will start with 1, right? And then again, you can continue adding with what with that 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and then add them, and this is the final function you get. Right? For these 2 lines of coding, you have to do 3 pages of algorithm, right? To understand the back end of every code in Python. Is it clear now, Sharon?
Yeah, teacher, it is.
Then again, you obviously don't understand what is for I in this case, but you understand the range over here, right? We understand this range from your condition given in the step 5. If n is less than equals to 1, less than equals to 10, that means n can never be 11, and n starts with 1, right? So that's where the range is 1 and 11. So you're going to get the square for the first 10 numbers. So 1, 2, 4, 5, 6, 7, 8, 9, 10. Right? These are the values that you're going to get. So then, this is it for your first Decision Maths 1 class. I'm going to stop the class over here, and from next week onwards, our classes will be on Friday at 9 a.m. of your time. Okay. This week I had some problems, so we cannot conduct that on Friday, but next week onwards, we're going to have our classes on Friday at 9 a.m. Also, this slide will be given to you, and I'll try to give you the link for the Python tutorials if you want to continue with understand Python a little bit for your entrance exams in universities. Okay, then thank you for joining the class. I'll stop the class over here. Bye bye.
Bye, teacher. Thank you so much.